Good afternoon, everybody. It's indeed a pleasure meeting and getting the opportunity of interacting with the students of a very, very coveted program of IGNOU, that is Masters in Computer Applications. Well, I'm neither a student of computer science nor a student of statistics, but I came to know that the learners have some problems in this particular area, which is known as statistical computing and probability distributions. So I offered that I can just take a chance of interacting with them, and if I can be of any help to them, I'll definitely feel happy about it. I welcome the students who have come to the studio of EMPC in this scorching sun, and also the students who are sitting all over the country and watching this program. Please feel free to ask questions, because unless and until we have interaction, our doubts cannot be clarified. And please don't feel that you are going to ask a foolish question, that what sir would feel that perhaps I'm asking a very foolish or a stupid question. And if you feel like that, then my message is, it is better to be foolish here than to be foolish at the examination hall. So don't worry about. If you have any query, don't hesitate, and please feel free to interrupt me and raise your question. Now, I'll be having 2 sessions today in this cycle. I think 2 sessions tomorrow and 1 session on Monday. And the portion which I intend to cover is this probability distribution, starting with random variables, and then which I intend to cover in these 2 days, because I'll be taking up 3 very important distribution functions, that is the binomial distribution, the Poisson distribution, and the normal distribution, which is so much used. Also, I'll try to see if I can accommodate chi-square distribution. And then on Monday, perhaps we'll be taking up the regression line, that is the method of least square fit. This is all that I'll be able to accommodate in these 5 sessions that have been allotted to me. Now, you must have gone through your study materials, or you have not received your study materials so far. Oh, this was one area about which I was told that the study materials have been prepared late, and that was also one of the reasons that the students are facing a lot of hardship. And in order to mitigate this hardship, we thought that we should have certain additional sessions apart from what you are going to have at your study centers. Now, first of all, what is a random experiment? Anyone has any idea what is a random experiment? What is an experiment? Tell me. Now, the very expression experiment gives us the concept, say, of a laboratory, isn't it? That a physics laboratory or a chemistry laboratory or a life science laboratory or a nuclear lab, a very high-tech lab, where some experiment is being performed. And of course, you do not know the outcome, but maybe you have framed a hypothesis. If you are students of science, say you are trying to determine, say, the refractive index of glass. You are trying to verify, say, Snell's law. You are trying to work out the focal length of a convex lens. Or say you are trying to find out the nature of a reagent, the acid radical of a salt, the basic radical of a salt. So those are the experiments which you perform in a laboratory. But what is a random experiment? A random experiment always caters to a random variable. The other name is stochastic variable. You should be aware with this name, stochastic variable. That is a random variable. Now, a random variable is something which is associated with a random experiment, and it is always linked with a number. That is very crucial. It is always linked with a number, and the number is such that you cannot predict. The number is such which you cannot predict. Say I have a coin. I am tossing it thrice. This is the first toss. The outcome is head. I didn't know whether the outcome would have been head or tail. This is the second toss. The outcome is tail. And this is the third toss. The outcome is again tail. So what has been the outcomes? Head, tail, tail. So how can I associate a number? Well, you try to replicate this situation. Say for instance, what I have done is equivalent to tossing 3 coins, isn't it? I had indeed tossed 1 coin thrice, right? But this can be replicated, or this can be thought of as equivalent to 3 coins being tossed and the outcome being head, tail, tail, isn't it? So, what kind of number you can associate with this kind of an outcome? Speak little loudly. They can be given the microphone. You have the microphone. No, speak in the microphone. Whenever you have to speak something, take the microphone and say, so that other persons can hear you across the country.
In terms of 0 and 1.
0 and 1. Okay. And how do you associate 0 and 1 with this?
We can give
Speak to the
we
microphone.
can give 0 to heads and 1 to tail.
Okay,
or
that is
vice
one
versa.
way. That is one way. But then in that case, you have to associate those numbers 0 and 1 to each item. Now, first of all, in order to describe a random experiment, you have to describe an event. Now, the event is 3 coins being tossed. The event is 3 coins being tossed. And the simple number outcome can be number of heads. Okay? Number of heads in the toss of 3 coins. Is it all right? Is it making sense? Huh? Number of heads in a toss of 3 coins simultaneously. So, the number of head here is 1. It could have as well been head, head, tail. So, this is 1, this is 2. Had it been head, tail, head, what would have been this number? Yes? Speak loudly. Why 3? Number of heads, I have described the event as number of heads in the toss of 3 coins simultaneously. So, this is also 2. Had it been head, 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 then had it been tail, head, head, huh? Had it been tail, head, tail, 1. What are the other possible outcomes? How many total outcomes will be there? Can anybody tell? You are saying 9. What's the rationale for saying 9? For each coin, there are how many possibilities? 2. So, for 1 coin, there is 2 possibilities. So, for 2 coins, there are how many possibilities? 2 into 2, 4. So, for 3 coins, there are how many possibilities? 2 into 2 into 2, 8, not 9. Okay. So, now find out those whether, so I have only spelled out 6, right? Which are the other 2? Fine, tail, 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 very good. Head, head, head has already been taken. So, tail, tail, tail would be, what would be this number? 0, very good. And only one more outcome is left. Tail, tail, head, fine. So, what is this number? 1. Head, tail, tail, head, head, tail, head, tail, head, 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 head. So, this time I have developed it randomly. You can do that very systematically. Say first you start with 1 coin. The outcomes can be head or tail. Make it 2 coins. So, you associate head with this. Again you write head, tail. This is coin number 1 and this is coin number 2. So, initially it was this head, tail, corresponding to that you can have head in 2. Again you write head, tail, corresponding to that you can have. So, these are the 4 outcomes: head, head, tail, head, head, tail, tail, tail. Now, bring in the 3rd coin. So, this is the set of 4 outcomes of the 2 coins. Again you repeat this: head, head, tail head, head tail, tail tail. Now with these 4 you can associate the head outcome of 3 and the tail outcome of 3. So now we have got all the 8 outcomes very systematically. Try to match them. See, tail 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 is here. Okay. Head tail tail, where is that? It is here. Right? Then where is this one? Tail head tail. Tail head tail. Sorry. Tail head tail is here. Where is head head tail? Here. Okay. Where is tail tail head? This is here. Where is head tail head? This is here. Where is tail head head? This is here. And where is head head head? This is here. It should exactly match, right? The 8 outcomes which we have got here systematically, here we are doing it randomly. We are not doing it systematically. But here we had done systematically. So I tried to show you that they match. Unless they had matched, then either of the processes would have been wrong, isn't it? But now we are sure that both the processes are correct and we arrive at the same result. So you understand that the meaning of a random experiment, and this is perhaps the most prolific example which will be taking up time and again, the toss of a coin, right? Any other random experiment? So random experiment is one whose outcome is in the form of a number and that number cannot be predicted, right? So what was the number here? Number of heads. So you understand how I negated your 0 and 1. It was a good idea, but I negated that because the event is number of heads in toss of 3 coins. Okay, right. Now you tell me, give me another example of random experiment. Dice, define the event. हिंदी में बताइए. Outcome when you roll a die. See, this is a die. I have prepared it for you. Have you seen a perfect die? What is the what is the characteristic of a perfect die? देखिए इसको. See it. Show it to everybody and tell me what is the characteristics of a perfect die. And while you see it, I am also mentioning about other random experiments. Say number of you have not travelled along, say, a particular road. You do not know the road. You are encountering that road for the first time. आप लोग ये देखते रहिए और साथ साथ सुनते रहिए. And you have to tell me what is the characteristic of a perfect die. Now you have not encountered that road. You are travelling along that road, say, for the first time. Now number of 4-story building in that road. Is this a random experiment?
It can be counted.
So you can associate a number with that, and you did not know that number beforehand. So this is a random experiment. When you read a book, number of misprints per page. Is this a random experiment? Right? Because again, when you read a book, you do not know the number of misprints, and that can be countable. Number of telephone calls you receive, say, between 1 p.m. and 2 p.m. Is it a random experiment? So now you give me an example. I have given you so many examples. You give me an example of a random experiment. With the die, give me a random, you said something like die. So, describe in the form of an event. Q. Doesn't every face of the die have a number? I have not shown it in the form of dots. I have just written the number. Say this is 1. What should be on the back side of 1?
6.
Why?
It is a first number and its back should contain the last number.
It's not exactly like that. Whatever you have said makes sense. In fact, the 6 numbers on the faces of die are 1, 2, 3, 4, 5, 6. So have you ever bothered to take the total of that? The total of that is 21. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21. And there are how many pairs of opposite faces? 3 pairs of opposite faces. So this is a pair of opposite face, this is a pair of opposite face, this is a pair of opposite face. So there are 3 pairs of opposite faces. So divide 21 by 3. What's the result? 7. Now the opposite faces of a die must add to become 7 always. That's what I wanted you to check, whether or not it's a perfect die. The opposite faces of the die should add together to become 7. Now you can check that whether it has happened or not. So when you roll a die, you get a number. When you roll a die, you get a number. So you gave the example of die. That's a prolific example. Why couldn't you describe? आप hesitate मत करिए, बताइए. When you roll a die, you get a number. So the number obtained on rolling a die. Now before you roll a die, do you know that number? So you do not know the outcome. You cannot predict the outcome. But the outcome is a number. So it is fulfilling the 2 conditions which I said. That the outcome should be a number and the outcome is non-predictable. Right? So what are those numbers? 1, 2, 3, 4, 5, 6. Now each random variable is associated with a probability. What is the probability of getting a head? I hope you have studied probability, or you have not studied probability at all. Probability is a very, very important concept. Anything which depends on chance has got with it associated this particular term, probability, which has got associated with it some chance factor. Australia is playing against Sri Lanka in the final. Who will win? What's the probability of Australia winning? What's the probability of Sri Lanka winning? You dig at a particular place, whether or not you will be getting oil there. ONGC does this experiment, right? You are appearing for a selection committee, you are appearing for an interview, whether I will be getting selected. So these are all things, and then again coming back to the very prolific example that you toss a coin, whether it would be a head or a tail, right? So these are all events which has chance factor, and there are things associated with a real life situation. I gave 2 examples with real life situation, appearing for a selection committee, whether or not to get selected. ONGC drilling at a particular place, whether or not to get oil at that particular place. They do that experiment. Not only in the land mass, if you have heard about Bombay High, they go to deep seas to explore oil. So even if there are chance factors, decisions are to be taken, right? Even if there are chance factors, decisions have to be taken. And to facilitate yourself taking such decisions, we fall back on the aspect known as probability. Now in order to have the definition of probability, again 3 conditions are to be fulfilled. First of all, the total number of outcome of all those events should be exhaustive. What is meant by exhaustive? The events, so the experiment which you perform is called a event. The random experiment, it is called, otherwise a random experiment. Again describe these 2 random experiments quickly. This, what was this random experiment? Please describe quickly.
Probability of getting
Not probability तो मैंने अभी बताया. What was the random experiment? Number of heads in the tossing of 3 coins. Why are you getting confused? The number of heads in the toss of 3 coins. And describe this event, this one, with the die. रखिए रखिए आपके पास रखिए. The outcome or the on or ऐसे कहिए, the number on the top face when you roll a die. You can see other numbers also. No? When you roll a die, you can see other numbers from the sides, but you always give cognizance to the number which comes on the top face. So you should be able to describe properly. आप हिंदी में बताइए. So now please tell me these 2 events. You describe the first one. जल्दी करिए, time is running out.
Reading the number of heads.
Don't say reading the number of heads, just say number of heads.
Number of heads.
Number of heads in the toss of
3 coins.
3 coins. And दूसरा वाला?
Getting the number on the top of die.
The number on the, getting the number, क्यों? The number on the top face when you roll a die. अच्छा. So this is called a random experiment, in short, event. Now the outcomes should be exhaustive. The first condition is, before defining probability, the outcomes must be exhaustive. What is meant by that? What is meant by the word exhaustive? Like when you toss a coin, what are the possible outcomes? Head and tail. Don't say head or tail. Head and tail. What are the possible outcomes? It's head and tail. इसके अलावा और तो कुछ नहीं हो सकता है. It cannot be anything other than head and tail. So these 2 events are exhaustive. अब मान लीजिए the coin drops like this and gets stuck up, जैसे शोले फिल्म में एक बार हुआ था. So then what is the outcome? आपने कह दिया tail and head. If it drops like this, and I've got a place, say it drops like this here, then what is the outcome? Neither head nor tail, na? So the experiment should be performed in a condition where such thing does not happen. Maybe it is little bit stretching things too far, but I have been able to cite an example where such a thing has happened. Again, perhaps I am stretching things too far. Suppose you have a coin which is filled with hydrogen gas. So then if you toss it, it would not come back. It would go up. Isn't it? So such sort of things should not happen. The events must be exhaustive. का मतलब समझ गए ना कि the 2, 4, 5, any number of outcomes, whatever possible outcomes you have in your mind, that should be exhaustive. Nothing can happen beyond that. Achha. Then number 2 is they must be mutually exclusive. What is meant by this? Mutually exclusive. Mutually exclusive. एक दूसरे को exclude करता है. One excludes the other. Suppose I say that I am Mr. A, he is Mr. B. I say that if he is in the team, then I am not going to play. So A and B, and he also says that if I am in the team, he is not going to play with me. So A and B become then mutually exclusive. तो इसमें क्या मतलब है mutually exclusive का? That every outcome excludes the other. Again, I am citing this example. मतलब ऐसा नहीं होना चाहिए. मान लीजिए you have called head and it drops like this, then you will claim that it is head. मैं इधर से देखता हूँ tail, I will claim that it is tail. So it should not happen like that. Or it often happens in the Ludo board. You give your exercise book just for a while. If it often happens in a Ludo board that if the board is like this and the dice get stuck up here, So I want the outcome to be 4 so that your coin can be cut. So from this side I am seeing 4, from that side say you are seeing 2. So then we land up quarreling with each other. झगड़ा हो जाएगा. तो ऐसा नहीं होना चाहिए. It should be mutually exclusive. One outcome should be able to exclude every other outcome. That is, when it is 1, it is 1, nothing else. When it is head and nothing else. So event should be mutually exclusive. And then third is most important. They must be equally likely. Don't write first. ये हैबिट तो छोड़िए, तो किताब में भी लिखा हुआ है. Don't think that whatever I am saying is Gita. No, I mean it. Wherever you interact with a teacher, always try to develop your understanding. First make your understanding clear and then put into black and white. So first let us understand. You will be able to write when you understand. What is meant by equally likely? That is, there is no bias. There is no bias. Say, give me the die. Say it is prepared with such thing that this bottom portion is heavy. Towards 5 it is heavy. So it will always come 2. Or very often it would come like 2. Or even that example which I was citing, Australia versus Sri Lanka in the final. So always odds were heavy in favor of Australia. It's not that the probability of Australia winning was half Sri Lanka. If it is equally likely, it is half. But then there would not be any bookies and other things. That the odds in favor of Australia is 70% means it is not equally likely. The outcome is not equally likely. If a very strong team is pitted against a weak team, then the bias is always heavier on the side of the strong team, on the side of the stronger team. So there you cannot say the events are, I beg your pardon, the outcomes are equally likely, right? So if these 3 conditions are satisfied, that they are exhaustive, they are mutually exclusive, and they are equally likely, then the probability of A, we express it like this: probability of an event A is number of outcomes favorable to A divided by total possible number of outcomes. अब बताइए हेड का प्रोबेबिलिटी कितना है? प्रोबेबिलिटी ऑफ हेड एंड प्रोबेबिलिटी ऑफ टेल बताइए.
1 by 2, 1 by 2.
Because total number of outcome is 2. So first, I think first you clinch the denominator, right? इसमें भी total number of outcome is 2, and out of those 2, how many are favorable to head? 1. Out of 2, 1 is head. So this is half. This is half. What is the probability of each event here? 1, 2, 3, 4, 5, 6.
1 by 6.
Very good. So total number of outcome is 6, and the number of outcome favorable to 1 is 1, favorable to 2 is 1. Achha, what is the probability of getting an even number when you roll a die? What is
Half.
fine? So there are total number of outcome is again 6, and number of outcome favorable to even number is 3. So it is 3 by 6. That is half. Achha. Then if I say what is the probability of an outcome which is divisible by 3? What is the probability of an outcome? Pardon? Pardon?
1 by 3.
Why 1 by 3? What is the total number of outcomes?
Total number of
Outcome is always 6. And how many of them are favorable to being divisible by 3?
3 and 6, 2.
So,
2 by 6 is
2, acha, you said 1/3. Acha, sorry, you are right. So it is 2 by 6. 2 by 6 equal to 1 by 3. Okay. So now, let us go to these kind of compound events, right? And try to work out the probability. Okay. So in the case of one coin, you have worked out this, right? Now say we have 2 coins. In the case of 2 coins, outcome can be, as you have said, head, 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 tail, tail, head, and tail, tail, right? Now, how many total number of events? 1, 2, 3, 4. These are the 4 outcomes. And out of these outcomes, how many are favorable to 2 heads? So the probability of 2 heads, if you say probability of 2 heads, it is 1 by 4. What is the probability of 1 head? Now how many outcomes are favorable to 1 head? 2 outcomes. So this would be 2 by, and this is equal to half. And no head, again. So directly by observing the events you can find out. Then we come to the first problem which I had shown. Now tell me, in the case of tossing of 3 coins, you remember this is the situation of tossing of 3 coins. I showed with 1 coin, but this is equivalent to tossing 3 coins simultaneously. So what is the probability of, let me write down the outcomes. 3 head, 2 head, 1 head, no head. You follow this, no? So what is the outcome of, what is the probability of 3 heads? 1 by, very good. What is the probability of 2 heads? 2 heads. How many cases are favorable to 2 heads?
3 by 6.
See, this is favorable to 2 heads, this is favorable to 2 heads, this is favorable to 2 heads.
3 by 8.
So that should be 3 by 8. 1 head. How many again? See, this one is 1 head, this one is 1 head, this one is 1 head. So this again is, and no head.
1 by 8.
No head is this one, so it is 1 by 8. Very good. Now let us see the total. What is the total here?
1.
So the total here is half plus half 1. What is the total here? So 1 by 4 plus half plus 1 by 4. The total is again equal to 1. And what is the total here? The total here is 1 plus 3 plus 3 plus 1 by 8, which is 8 upon 8 equal to 1. So what do you gather from this? That is, combination of all those outcomes is a surety. If I ask you, that's why I was objecting when you said tail or head. Now if I ask you that I toss a coin, what is the probability of getting tail or head? Go by the formula. How many outcomes? No. How many outcomes is 2? How many outcomes is always 2? And numbers favorable to tail or head? Why 1? Tail or head. If it comes head, that is favorable. If it comes tail, that is also favorable. So number of outcomes favorable to tail or head is, so numerator is 2, denominator is 2. The result is 1. Okay. So now I say that if I toss 2 coins, what is the probability that it is either 2 head or 2 tail or 1 head and 1 tail? Again 1, right? But if I say that if I toss 2 coins, what is the probability that it is 1 head and 1 tail? Then it is, how many outcomes are favorable to 1 head and 1 tail? How many outcomes? These are 4 outcomes. 1, 2, 3, 4. Out of these 4, how many are favorable to 1 head and 1 tail? So it is 2 by 4 equal to half. So like that. Now you can also calculate it directly, like the probability of getting 3 heads is 1 by 8. So probability of getting 1 head is in the toss of 1 coin is half. That is associated with the probability of getting one head in the second coin, and that is again associated with probability of getting 1 head in the third coin. So this is 1 by 8. So the probability of head, head, head can be worked out like this. Now, what is the probability of getting head in the, now you observe the events very carefully. Now, how I am describing this outcome? Head in the first toss, tail in the second toss, and also tail in the third toss. So what is the probability of head in the first toss? 1 by 2. So why are you taking time to tell that? Head in the first coin. So this is an independent event. You toss the first coin, the probability of head is half. Tail in the second coin, tail in the third coin, also half. So probability of this outcome is also 1 by 8. So, but here I have shown probability of 1 head is 3 by 8. So where is the discrepancy? There is no discrepancy, because you can get 1 head in 3 mutually exclusive ways. You can get 1 head in 3 mutually exclusive ways. This is one of those ways. The other way is which one? This one. This is the other way of getting 1 head. Now this event and this event are mutually exclusive. You just see, in the first coin here it is head, in the first coin here it is tail, in the first coin here it is tail, in the second coin here it is tail, in the second coin here it is head. So these are mutually exclusive, right? So these are 2 mutually exclusive ways of getting 1 head, and this is another mutually exclusive way of getting 1 head. Because if this happens, this is not going to happen. If this happens, none of these 2 are going to happen. So you have 3 mutually exclusive ways of getting 1 head, right? And then in each case the probability is 1 by 8. As we had worked out, probability of head in the first toss is half into half into half. It is 1 by 8. Here also it is half into half into half. Again 1 by 8. Half into half into half. Again 1 by 8. And then you can say that the probability of getting 1 head is the sum of these 3 cases. You have got 1 by 8 in the first case, 1 by 8 in the second case, 1 by 8 in the third case. Why I am adding them? Because they are mutually exclusive, right? So these are the 3 mutually exclusive ways of getting 1 head in the toss of 3 coins. So 1 by 8 plus 1 by 8 plus 1 by 8 is equal to 3 by 8. And if you have taken the idea of combination, you have studied permutation and combination, no? Huh? So see, that way also I can arrive at the figure 3 by 8. How? Because that would be the starting point of the next session. See, let us define P as the probability of success. And Q as the probability of failure. So let us call H as success. Okay, getting head is a success, getting tail is a failure. So you did not have to associate the exact meaning of the term success and failure. The literary meaning of success and failure did not do there, but it's a very convenient way, because if the probability of success is P and probability of failure is Q, then P plus Q is always equal to 1. Because these are the two outcomes. Say if head is success, then probability P is half, tail is failure, Q is also half. Half plus half is 1. Say in the toss of in the roll of a die, suppose you reach home if the first face is 1. The probability of getting 1 is what? 1 by 6. And probability of not getting 1 is? Not getting 1. Not getting 1.
1 minus 1 by 6. 7 by 6.
Why 7 by 6?
5 by 6.
Because how many outcomes are favorable to not getting 1? है ना? There are 6 outcomes. Out of that, 1 outcome is 1. So there are 5 outcomes which is favorable to not getting 1. Okay. So that is 5 by 6. So again you add 1 by 6 plus 5 by 6 is how much? 1. So P plus Q is always equal to 1. It need not be that they are same. If you call getting 1 as success, then not getting 1 is failure. Right? So there you get P plus Q is equal to 1. Right? So now if head is success, then getting, so P is equal to half in the case of toss of coin. So getting success in 3. Getting success in 3 is half to the power of 3. And once you get success in 3, then you fail in. So there is 0 failure. So half to the power of 3 into half to the power of 0. And you are choosing 3 heads in 3 coins. So that should be 3C3. 3C3 is 1. So it comes to 1 into half cube, and half to the power of 0 is again 1. So this is 1 upon 8. Here it would be, in this case again pick up any one of them. Failure, success is half, failure twice. Probability of success is half, probability of failure is also half. So again it is half to the power of 3. And you are choosing 1 head out of 3. So it is 3C1. So half to the power of 1 into half square is half to the power of 3, 1 by 8 into 3. So it is again equal to 3 by 8. We will start from this when we take up the binomial distribution. Thank you.